discussing the force analysis of worm gear drive. To understand the forces which are exerting on the worm and the worm gear in worm gear drive, we are considering the front and side view of worm and worm gear machine. If we see the first figure, this first figure is showing the front view, in which the this cylindrical portion is the worm and this circular portion is the worm gear. Okay, now we are considering the force exerted by the worm gear on the worm. If we see the force which is exerted by the worm gear on the worm in the axial direction, we have considered this as a axial force, and the force which is exerted by the worm gear on the worm in the radial direction, we are considering it as a radial force, that is Fr. Now if we consider the side view of the same machine, we will have the periphery of the worm and the tangential force will be acting along the periphery in the direction of rotation. Okay, so what will be the forces which are exerted by the worm gear on the worm will have the equal and opposite reaction on the worm gear. So we can establish the relationship between the worm forces and worm gear forces, because they are having the equal magnitude but in the opposite direction. One thing is more here has to be draw some attention that the worm and worm gear are transmitting power at 90 degree. Okay, and if they are transmitting the power at 90 degree, that means the axial direction for the worm will have the tangential direction of the worm gear. So if we consider the relationship between axial force on the worm and the tangential force on the gear, we will have the relationship like this. The tangential force on the worm is equal to axial force on the gear. That means the tangential force which is acting over the worm having the axial force is, that is, this force is equal to the axial force on the gear. If we see this Ft is tangent to the this worm, but if you see the axis of the gear is this, so this Ft is having equal amount of force in the direction of axis or parallel to the axis of the worm gear, but these forces must be in opposite direction. If these two forces are in the same direction, what will happen? The gear drive will not be in equilibrium, and we never want any system in the non-equilibrium condition. So each and every force will have equal and opposite reaction to have the drive in the equilibrium. Okay, now the axial force on the worm, if you see the axial force in the worm, this Fa is along the axis of the worm, but if you see this same force is tangential to the worm gear. So the axial force on the worm will equal to the tangential force on the worm gear, but it will be the opposite direction. Similarly, the radial force, if you see the radial force in the worm and radial force in the radial direction in the gear are same, so the radial force or the separating force on the worm is equal and opposite to the radial force of the gear. So this is the basic relationship between the worm forces and the worm gear forces. Now we have to establish the relationship between the tangential force, axial force, and the radial force. If we are able to establish the relationship between the tangential force of the worm, axial force of the worm, and the radial force of the worm, then we can definitely establish a relationship between the axial force of the gear, tangential force of the gear, and the radial force of the gear. So we are considering the worm forces. Now, in the next slide, what will we do? We consider a worm and consider all the three forces acting on that worm, and we will try to establish the relationship between radial force, axial force, and the tangential force. Okay. Now, in general, we are considering that the worm gear drive is in static condition. That means it is about to move, but had not started rotating. Okay. Why we are considering this? Because as and when the worm drive start rotating, there will be a friction force, and we have to consider that friction force when we are analyzing the forces. So what we will do, we will first establish the relationship between the tangential, axial, and radial forces when the drive is static. Then we will consider the friction forces. So first of all, what we are doing, we are considering the forces when the drive is in static condition or just about to move. They are in contact and they are just about to move, but have not started the rotation. So if we consider in general, the power is to be transmitted is known, and at what speed we have to transmit that power is known. So we can easily find out the tangential force on the worm, and the tangential force on the worm is equal to power divided by velocity, peripheral velocity or the tangential velocity of the worm. So Ft is equal to P by V, where P is the power and V is the tangential velocity of the worm. Okay. Now that means the magnitude of Ft is known to us. Okay. Now we consider a worm having the helix. This orange line is showing the helix of the worm. We are considering single helix on the worm. Okay. So I have drawn this circle just to show the direction of tangential force. Okay. This will be the direction of tangential force, and this tangential force will be exerting over the pitch point where the two worm gear and the worm is under the mesh. Okay. We are considering the rotation of the worm in the clockwise direction. So the tangential force will be in this direction. Now the pitch point is this. So the axial, where is the pitch point? All forces will be exerted at that point. So we are considering the axial force in the direction, as we have seen in the earlier figure. This will be the radial direction, and the tangential force will be parallel to this, tangent to this pitch circle. Okay, pitch circle of the worm. So we have drawn the Ft parallel to the tangent to the pitch circle. Okay, so these are the three forces which are acting over the pitch point on the worm. Okay, now we have to establish the relationship between Ft, Fa, and Fr. So for developing the relationship, we are considering this helix here. We are considering the same helix which is on the worm. We have drawn this helix here so that we can easily understand the figure of the force diagram. Okay. Now these are the three forces which are acting here. This is the radial force, this is the axial force, this is the tangential force. Okay. Now the only known magnitude of the force is Ft, that is P by V. That is known to us. Now if we consider the normal pressure angle, the normal pressure angle is nothing but it is the angle between the resultant force of these three forces and the line perpendicular to the helix. So we know this angle. This blue line, this sky blue line is perpendicular to the helix. This angle is 90 degree, and this red line is the resultant of these three forces. So we have considered these two lines, the red line as a resultant force and this blue line perpendicular to the helix, and the angle between these two lines is phi. So we have drawn a perpendicular line to the helix and draw the your normal pressure angle, which is known to us for the geometry of the worm gear, and draw a resultant. Now, if you want to find out the axial force, what we will do? We will draw a parallel line to the axial force from the Ft. As Ft magnitude is known to us, so what we will do? We will draw a parallel line from the end point of the Ft, and this parallel line will cut the perpendicular line at point this. This will determine the magnitude of axial force. Now, as the axial force magnitude is known, so we can draw the magnitude of radial force. Now, the radial force will be what? Parallel to the. Now, what we will do? We will draw a line at the point of intersection of line perpendicular to the helix and the axial force magnitude line. That is this. Now, this line parallel to the radial force, this purple line will cut the red line at some point on the resultant force, and this will limit the magnitude of the radial force. Now we can develop a parallelepiped for completing this force analysis diagram like this. We will draw the parallel lines to the tangential force. We will draw the parallel line to the radial force. We will draw the parallel lines to the axial force. Now we are having this parallelepiped, which is the force diagram of all the forces exerting on the worm. Okay. Then now we will consider the geometry. If you see the angle between this resultant force and this line perpendicular to the helix is pressure angle. If we consider the angle between this sky blue line that is perpendicular to the helix and the axial force, it is nothing but it is the lead angle, because the definition of the lead angle is the angle between the pitch helix and the line perpendicular to the axis. So if this is the angle gamma, then that means the line perpendicular to the axis and the line along the pitch helix of the worm is lead angle. So the perpendicular of those two lines will also have made the lead angle gamma. Okay. So if you see, this is what this blue line is perpendicular to the pitch helix, and this yellow line FA is perpendicular to the line perpendicular to the axis of rotation. That means this FA is along the axis. So this angle will be lead angle. Okay. Now we are giving the name of all the pointed points. We have given the name this point A, B, C, D, E, F. Each point is O and H. Now we are considering the triangle OAB. The triangle OAB is triangle OAB. Okay. If we are considering this triangle, we can write down these two equations. That is, this yellow line is equal to the FA and this green line is FT. So we can easily write down if this angle is gamma, so this angle OAB will also be gamma because it is an alternate angle. So we can write down FA is equal to F. This OA we have termed as F. The line OA, magnitude of line OA we have considered F. So we can write down FA is equal to F cos gamma and FT we can write down F sin gamma. Similarly, if we consider the triangle OAD, OAD, this sky blue line, this purple line, and this red line. If we consider the triangle OAD, then we can write down F OA F is equal to FR cos phi. F is equal to FR cos phi. And the radial force, that is the purple line, is equal to the FR is equal to F resultant force multiplied by sin phi. So in this manner we can find out the F in terms of resultant force, FR in terms of resultant force. If we put the value of F, in these two equations, we are able to find out the FA and FT in terms of resultant force. Okay, and this FT is known to us because the magnitude of tangential force is known. We can easily find out the resultant force. Once we find out the resultant force, we are able to find out axial force. By knowing this tangential force and having this relationship, you can find out all three forces which are acting on the worm when the drive is in static condition or is just about to move. Now we are considering the motion of the drive. Now the drive has started to move. As the drive has started to move, what will happen? The gear will slide over the pitch surface of the worm, and there will be the friction between the worm and worm gear. As the friction will become into picture, so there will be a friction force. Now we have to find out the direction of friction force. So the direction of the friction force will be, it will be parallel to the pitch helix of the worm. It will be parallel to the pitch helix of the worm. Okay, and it will be in the direction of rotation of worm. Why it will be in the direction of rotation of worm? Because the worm gear is slipping over the pitch helix of the worm opposite to the worm gear rotation of worm gear. Rotation of worm. If we consider the slipping of your worm gear over the worm, it is in the opposite direction of the worm rotation. So the friction force will be in the direction opposite to the slipping. So this will be this light green line will be the friction force, and this friction force will have again having the two component. The angle between the force along the tangential direction is lead angle. Okay, because what is the lead angle? Lead angle is nothing but it is the line perpendicular to the axis and the pitch helix. So tangential direction is always perpendicular to the axis of rotation, and this light green line, that is the friction force line, it is along the pitch helix. So this angle will be gamma. Now we can resolve this friction force into two components. One is along the axial force and other is along the tangential direction. So these are the two forces which have been resolved in axial direction and tangential direction. The component of the axial direction will oppose the axial force which is exerted in the static condition, but the component of the friction force in the tangential direction will act along the tangential force which was exerted when the drive is in the static condition. So this is the direction of friction force in the axial direction, and this will be the direction of friction force in the tangential direction. So now we can find out the net tangential force on the worm, and the net tangential force on the worm will be the tangential force when the drive is in static condition plus friction force. We can easily find out the net axial force, that is the axial force when the drive is in static condition, and minus friction force, because the direction of the component of friction force in the axial direction is opposite to the axial force, so it is minus. And net radial force, because the friction force nothing has to do with the radial direction, so friction force will be same. Now here, by knowing the Ft, we can easily find out Fr, that is resultant force. By putting the value of Fr in Fa equation, we can easily find out the value of axial force, and finally we can able to find out the radial force. So with the help of these three equations, you are able to find all the possible forces on the worm gear. Okay, now we have to find out the efficiency of your worm drive. To find out the efficiency of the worm drive, why we are finding out the efficiency of the worm drive? In the other gear, we never find out the efficiency of the drive. Here, there is a friction, so there must be some power loss in the friction. So, if the power loss is in the friction, there must be a efficiency. And the efficiency of the worm gear is nothing but, if you see the efficiency of any drive is power output upon power input. And what is the power output on the drive? That is torque on the gear. That is what will be the torque transmitted to the gear by the worm into angular velocity of the gear. And what will be the power input on the drive? The power input is on the drive will be the torque on the worm into angular velocity of the worm. Now, what will be the torque on the gear? Tangential torque is nothing but tangential force on the gear multiplied by radius of the gear. So we can easily find. But this tangential force on the gear is what? In the first slide, what we have seen this tangential force on the gear is nothing but axial force on the worm. So we can convert it into axial force on the worm multiplied by radius of gear. Now the angular velocity of the gear is 2 pi ng divided by 60. Similarly, torque on the worm, it is mistakenly written as gear, but it is torque on the worm. So torque on the worm will be tangential force on the worm multiplied by radius of the worm. And what will be the angular velocity of the gear? 2 pi nw divided by 60. Now we can write down the efficiency. Efficiency is nothing but torque into angular velocity of gear divided by torque on the worm multiplied by angular velocity of the worm. So 60 will be gone out. Okay, so we are having this equation. Now we have to simplify this equation. This will come out FAW into DG into NG divided by FTW into DW into NW, where DG is the diameter of the gear, NG is the RPM of the gear, DW is the pitch diameter of the worm, and NW is the RPM of the worm. Now we can put the value of FAW and value of FTW, which we have calculated in the previous slide. So we have write down the axial force value in terms of resultant force, and we have put the tangential force value in terms of resultant force. Now when we will simplify this, we will have this dg into ng divided by dw by nw can be written out as tan gamma. And how it can be written out? If you convert this value dg into m into zg. dg we are converting into m into zg, where m is the module and z is the your number of teeth on the gear. And if you convert this dw into q into m, that is q is the diameter quotient and your m is the module. So m will be cancelled out, and ng by nw is nothing but it is the 1 by reduction ratio. So ng by nw is 1 over reduction ratio. And if you want to write down dg in terms of reduction ratio, this dg will be comes out reduction ratio into number of start on the worm. So the reduction ratio will be cancelled out. We will have only zw by q, and this zw by q is nothing but tan of the lead angle. So this dg by ng divided by dw by nw can be written as tan gamma, and this will be the expression for your efficiency. That's all. Thank you. If you have any query, you can contact me on my mail, that is anurag.gupta@kiet.edu. Thank you.